Hi everyone, this is my little webinar on gas laws. Now, I'm going to introduce the experiment that I'd like you to do this week. It's quite an easy one. It involves a simulation. So you need to go into your web browser. This works on your mobile phone. It works on your PC, whether it's Linux, Apple. I think it probably work on an Etch-a-Sketch if you try hard enough. But the search you want to do is your Google search. Is PHET, otherwise known as FET, and we'd call them the gas properties. And that then enables me to play with the gas properties web simulation. So we're going to go into gas properties HTML5. Okay, there it is. Now, if you want to go into FET manually, you can go up here. If you end up here, then it's quite simple. You just click on play and it comes up. Now, this is a simulation. It's done using using a little sort of web app. It's pretty simple to use. We're going to click on ideal because it's the ideal gas equations. Hopefully by now, if you've done the work I've already given you before, you'll know what ideal means. You've got here a little box, and this box contains nothing at the moment. So the first thing we want to do is make sure that we put some gas in there. And the best way to do that is we pump air in. Now, once you've pumped the air in, you don't add or remove any. So we go 1, 2, 3, 4. Give it a little bit of a chance to settle down. Okay, it's at 300 degrees Kelvin, which is about room temperature. But I want you to change the temperature using this little down arrow here down to 27 degrees Celsius. So sorry, into Celsius rather than Kelvin, because although you've done some work on absolute temperature, we're going to find out what absolute zero is. So we're going to measure the temperature in degrees Celsius. Now, for this is the Charles Law experiment. Now, the Charles Law experiment is very, very clear that you keep the pressure constant, okay, but you want to vary the temperature. Whoops, like that, okay. So we're looking at the variation between the pressure and, looking at the variation between the volume and the temperature. So we're going to set the temperature using this heating and cooling mechanism here. We're going to measure the volume by clicking on width. And on width, it tells you how wide this is. Now, as this is a uniform chamber, the width is proportional to the volume. So you'd record that in arbitrary units in your table. So we might want to say start at quite a low temperature. So let's start at let's go down to about -9 or about 0 degrees Celsius. There we go. So 0 degrees Celsius, it'd be 9.1 nanometers. So you could use a table. Now, if you're feeling, as we're working electronically, you might want to use a spreadsheet. So the volume is in arbitrary units and was 9.1 nanometers. So that would be on here, 9.1, and we'd have the temperature and it would be in degrees Celsius. I accept if you just put a C in there like that, and that would be a 0. Now my autocorrect has decided to change that. So if I just give it a chance to not mess me about. There we are. So that was on to 0. And then all you do is you change the temperature. So you heat it up. So maybe I want to go to 20 degrees Celsius. 20 degrees Celsius, give it a second to settle down. And that's 9.8 nanometers. So again, that would be in my table, be 9.8 arbitrary units of volume at 20 degrees Celsius, and so on. What you then have to do is collect as many of those as possible for a nice wide range of temperatures, and then you draw a graph. I'm going to pause while I collect my data, and then you're going to be able to see what I mean by drawing a graph. So I've now taken a little bit of a break there with for you, because otherwise it's just watching me record data. So I've gone up to about 100 degrees Celsius, and I've got 12. My volume is 12.4 arbitrary units. Now this is a volume of gas. So we're looking at Charles' law, which hopefully you've read up on. If you haven't, you need to do that rather urgently. But what we're going to do is we're going to draw a graph. Now, I've deliberately put volume on the left-hand column here, because I'm going to draw a graph of the volume on the, which is going to go on the x-axis, and I'll put temperature on the y-axis, which is actually different from what you might have seen in the textbook. But this technique is actually particularly useful if you're using a spreadsheet. So it depends. Now, this depends upon which spreadsheet software you're using. I'm using LibreOffice here. You might want to use Excel, but the process is pretty similar. So you should be able to follow it if you watch what I'm doing first. So I've highlighted my table. I simply do that by dragging and dropping. So I've got all my values here. Notice I haven't got a repeat. That's because I'm using a simulation. So I'll always get the same numbers every time. You know that you've done that when you did some simulations earlier on in the year. So I'm going to go to Insert. Now in Excel, it's somewhere up here. There is actually the sheet, but I'm just going to click on Insert, and I'm going to insert a chart. And I'm going to insert an XY scatter. Now Excel has exactly the same language there. They call it an XY scatter. I don't want to put a line on yet, but I'm just going to put some points on there. So I've got set points. I click on Next. Data range is correct. That's fine. That's fine. I'm just going to click on Finish, and I get something that looks a bit like that. We are expecting a straight line because you've read in your textbook that there is a linear relationship between temperature and the volume of a gas. Now, what we're going to do now is I'm going to right-click on there, and I'm going to format my x-axis first, because I want my x-axis to go down to a large negative value. So the minimum there, I'm going to go down to minus 300. And here on my x-axis, again, I right-click with my mouse, format axis, and I'm going to go down to 0, because we want to see what the intercept looks like. Okay, and that gives you a graph that looks like that. So we've got temperature on the y-axis in degrees Celsius. We've got the volume in arbitrary units. Now, what I want to do is I want to find out the y-axis. Now, if you've got graph paper, you could just draw a line of best fit and then extrapolate that straight line backwards down to somewhere around about here. What I think I want to do is I'm going to add a trend line automatically. It's a neat little trick you can do with spreadsheets, and it helps you to measure the gradient. So I'm going to go to Insert a Trend Line, click on, and I want to show the equation. Remember that y equals mx plus c? That C part is the y-intercept, which is what we're trying to measure. So click on OK. Now it's not extrapolated it back, but it doesn't matter. It's given me my C value here. So that's then given me a value for absolute 0. Now here it's minus 277 degrees Celsius is 0 degrees Kelvin. But obviously your value will be slightly different because you'll be doing it yourself. So you will get slightly different numbers to the numbers I get. So when you come to hand this assignment in, I will know if you try to cheat, okay? So what I need you to do, very simple, is to basically do this experiment, take your results, draw your graph either manually on graph paper, or you can use Excel and find that y-intercept. So remember, we've got temperature on the y-axis versus volume on the x-axis. And what I'd like you to do is to then write that up so that you've quoted what your value for absolute 0 is. Mine is minus 277 degrees Celsius. Yours will be slightly different. We know that the accepted value is 273. So have a think about whether or not your value for that y-intercept is minus 273, or whether it's near to it, or whether it's just way out. Okay, you need to do that. You need to make that decision for yourself to decide whether or not you think you've got a reasonable answer there. So that's your work for this lesson, and to finish off the homework. And I'm going to ask for that in, please, on Monday morning by 9 a.m. So you need to email that to me. I would prefer it as a Word document so that I can read it and annotate it for you and mark it. If you want to do it by hand on a piece of paper and take a photo, please do. Just make sure it's not blurred or anything. I do need to be able to see it. Okay, I'll leave it at that. So you now know what to do.